In the next video, what we'll do is we'll apply some of the product quotient and power properties to simplify logarithms. So we're going to be using these same ideas about the properties of logarithms to help us simplify this. So let's take a look at log of base 6 of the cube root of 36. Now to me, the first thing I see is when I see the cube root of 36, I would really like to rewrite that as a rational exponent. So it's going to be 36 raised to the 1/3 power. Now hopefully you see a power rule that can be applied here. Rather than having the radical, which is really miserable to work with, I now have a power here, and we can use our power rule. And our power property says that if we take the log of a power, it's the power 1/3 times the log of that same value. So it's 1/3 log of base 6 of 36. Now I'm going to be looking at another way of writing 36. You wouldn't have to. You could probably figure out just from this statement, what is the exponent I raised 6 to get 36? Now that's what that statement is saying. What is the exponent I raised 6 to get 36? But I'm going to rewrite it a different way. Log of base 6 of 36, whoops, I want to rewrite 36 as a base 6 number, which is 6 squared. The reason I wanted to write that is because now that I have a log of base 6 of an exponential base 6, that's that inverse, get it spelled right, inverse property of logarithms. So these two cancel, so I have nothing more than 1/3 times 2, which is 2/3. Now I could have gone just a little bit different approach. I'm going to come back to this part right up here. And I'll just show you just the flexibility that you have with these is quite large. So you can have 1/3. You can take the log of base 6 and write this as 6 squared. And then once again we have a product rule, or I'm sorry, a power rule. The log of a power is the power times the log. So I can take this 2 and bring it down here, multiply it times the 1/3. So it's going to be 2 times 1/3 times the log of 6 of 6. But the log base 6 of 6 is asking you, what is the power I raised 6 to get 6? Well, that is 1. And that's another one of those properties that we looked at the other day. Whenever you take the log of base of a base of the same value of the base, it's just a 1. So it's still, again, 2/3. So a couple of different ways of looking at that, whichever one you prefer. You can probably work in both ways anytime you look at them. So next problem, in 2b, it's the natural log of e to the 9. Now there's your inverses again. There's that inverse property of logarithms. It's a logarithm of base e of an exponential base e. So those two reduce, and we get 9 plus. Then I got 4 times, and we're going to apply the same principle here. It's a natural logarithm of e to the 3rd. The natural logarithm and an exponential base e are inverses, so it's 3 times 4. And what we could get is just 9 plus 12, which is 21. A different path that you could take with this exact same problem is you could do this. You could apply, and this is probably more in line of what they're thinking, we could apply a power rule here and a power rule there. So it's the natural log of e to the 9 plus 4 times the natural log of e to the 3rd. And let's apply those power rules and see that we can get the same thing. The log of a power is the power times the log, so the 9 comes down. 9 times the natural log of e plus the log of a power is the power times the log, so it's 4 times 3, or 12 times the natural log of e. But when we take the natural log of e, it's asked you, what is the exponent I raised e to get e? And that is 1, so it's 9 times 1. Plus, and this is the same statement, so that's 12 times 1, or it's 9 plus 12, or 21. There's going to be a little bit of flexibility here in how you approach these, and there's not one correct way, but there are several correct ways that you can evaluate these logarithms using your product quotient and power properties.